there. My name is Mason Merkel. I'm a current environmental engineering junior at Purdue University. I currently work as a mechanical engineering intern for Train Technologies. And in the past, I worked as an undergraduate researcher for Purdue, as well as an intern for the Campus Master Planning and Sustainability Office. So I have tons of experience, especially in my current role, communicating between manufacturers as well as engineers in the overall process of bringing an engineering product and new technology to the market. So that's why I'm qualified to submit this design for the COVID-19 competition.
Hi, I'm Martina. I'm also an environmental engineering student at Purdue. I've also worked with Mason at Campus Master Planning and Sustainability, so we're both familiar with the constraints Purdue is placed under for certain projects. Currently, I'm an undergraduate research fellow under the SURF program, and I'm certified in AutoCAD.
All right, so to get started here, the project we're submitting is Viro360.
So the problem statement as it stands is that Purdue does plan to reopen for in-person classes this fall. The classroom surfaces can contain COVID-19 for hours and days depending on material, regardless of mask wearing and social distancing. All groups at Purdue will be at risk for COVID-19. And as much as we want to contain the virus to campus, students will have to grocery shop, return home, and interact with others. Since students pay a large sum of tuition to Purdue each year, Purdue has a moral responsibility to protect students and the community by creating COVID-19 virus-free rooms.
Transitioning from the problem to our solution of Viro360, our product is an inexpensive 360-degree disinfectant sprayer. It sprays table surfaces at time intervals with a refillable disinfectant cartridge. It's a portable surface model for mobility, and there's also an upscaled model for ceiling installation in large classrooms with larger surfaces.
So the current inadequate solutions that are in place are time and money spent on manual cleaning, which places a higher burden on custodial staff to constantly clean surfaces and can cause time constraints, which causes neglect of surfaces because of the short passing period in between classes. Another industry solution that other schools are considering are fog machines, which are expensive, slow, and require evacuation for long periods of time.
So the Viro360 design consists of a 360-degree disinfectant spray action, as you can see the holes there on the outer shell, which is removable to access the refillable cartridge that has a timer switch and an accessible programmable chip. We can program the chip so that the device is timed to spray between lectures or at night after classes. The device is mobile, and there's a sealing device as well, which is larger.
So in terms of financials, there would have to be an hourly worker in place currently that would have to be paid $10.53 per hour, and they wouldn't be able to do the other already existing aspects of their job in cleaning other areas of campus because they would have to spend 10 to 15 rounds per day to properly clean surfaces. The alternative, which is the Viro360 mobile unit, has a $20 fixed cost and only has one round required for an hourly worker per day to refill the cartridge in there. The average payoff period is 2 weeks, and the potential semester savings are upwards of $20,000 per building.
With benefits of this design come implications as well, which mostly lie in the sealing model. Because the sealing model involves spraying down onto surfaces, there needs to be a 20-minute passing period between lecture if used between each lecture, as opposed to the current 10-minute standard. This allows for the spray to fall to surfaces and dry, and again, this applies only to the sealing model and not the surface mobile model. There's also an implication of replacing the disinfectant canisters each week depending on room size and usage.
So the next steps are that the prize money would be utilized on mass production of Viro360, where $1,000 would pay for 52 mobile units or 28 lecture hall units.
If you have any questions, feel free to reach out to Martina or I for questions or feedback. Thank you for this opportunity.